China has just unveiled a radar it says can do the impossible, spot aircraft designed to disappear. This is the world's first programmable quantum radar, using entangled photons to see through stealth technology with remarkable clarity. It's a leap that could redefine how skies are monitored and how invisible objects are tracked. In this video, we'll explore how it works and why it's so groundbreaking. China claims to have built the first programmable quantum radar, a system that pushes detection beyond classical limitations using the uniquely odd science of quantum entanglement. At its heart, this radar works by creating pairs of entangled photons. When one photon is bounced toward a target, its twin remains at the source. Even if the bounced photon interacts minimally, the twin still reflects clues about that interaction, giving detection capabilities even when stealth technology tries to hide. This means the radar doesn't need a strong reflection to spot something. It relies on the subtle entangled connection instead. What truly differentiates this system is its programmability. Researchers at CETC, the China Electronics Technology Group Corporation, can adjust entanglement parameters, photon behavior, and sensor configuration in real time. This flexibility lets the radar adapt dynamically to different stealth designs or environmental conditions, such as electronic interference or atmospheric disturbances. It's like having a chameleon radar always tuning itself for optimal detection. Reported lab tests hint at longer detection range and greater precision than traditional phased array systems, especially when conditions are noisy or cluttered. While conventional radar needs strong echoes to track a target, quantum radar aims to listen to the entangled whisper that remains when echoes vanish. The claims are bold, but so far limited to controlled environments. In summary, this is a novel approach that ditches brute force reflections for delicate quantum fingerprints, combining that with real-time tuning and claiming better performance under deceptive or tough conditions. If this pans out beyond the lab, we're looking at a genuinely brand new chapter in detection tech. This quantum radar could reshape how hidden technology is detected, or rather, not hidden at all. Historically, stealth designs relied on reducing radar reflections. Quantum radar flips that dynamic entirely by detecting the quantum signatures left behind. Suddenly, aircraft thought to be invisible could become visible not through lasers or brute sensors, but through subtle entangled interactions. Think about this. Stealth aircraft accessible to radar only via faint echoes might now be revealed through quantum fingerprints, completely changing how detection systems are designed. For decades, stealth was a game-changer in military aviation. If quantum radar truly detects those with high fidelity, it could make stealth less of an advantage. This has immense ripple effects for nations who invested billions in stealth technologies and meant invisibility was their edge. The interesting twist is that stealth detection is no longer a one-way street. It becomes a two-way arms race. Nations like the US, Europe, or Russia might respond with counters, either enhancing stealth through new materials or developing its quantum detection systems. The geopolitical balance could shift toward whichever nation masters this new paradigm first. This is more than science. It's strategic positioning in a new technological frontier. Moreover, this radar could be folded into layered detection networks. Quantum sensors supporting classic radar, offering broader coverage and higher confidence tracking even under heavy clutter or interference. That hybrid model could redefine surveillance and monitoring, not just for national security, but for broader safety, from airspace control to sensitive site protection. In essence, this development is about more than one breakthrough. It hints at a systemic shift. Invisible becomes trackable, adaptable sensors become standard, and the rules of detection get rewritten. As thrilling as it is, the quantum radar doesn't come without serious hurdles. First, quantum states are fragile. Entangled photons are easily disturbed by noise, temperature shifts, or environmental turbulence. While lab conditions are controlled, real-world environments like open skies are noisy and messy, and maintaining entanglement over distance is a major technical challenge. Unless the system can shield or stabilize quantum states reliably, performance may fall short under operational conditions. Another obstacle is scaling and hardware complexity, or environmental turbulence. High-fidelity detectors and possibly cryogenic systems for precise measurement isn't trivial. The cost, maintenance, and technical requirements could be immensely more than those for a standard radar. Going from a lab demo to operational deployment demands miniaturization, ruggedization, and simplification, but that's easier said than done. Equally important is verification. So far, public claims come from CETC and Chinese media. Without independent tests or peer-reviewed data, it's hard to judge how far along the tech truly is. Analysts remain cautiously optimistic that this might be a powerful prototype, or it might be more of a demonstration of principle. Either way, extra scrutiny and transparency would help the global community assess its potential. Despite these hurdles, the future remains promising. Engineers may improve quantum memory, noise filtering, or detection algorithms to boost resilience. Hybrid systems combining quantum and traditional elements could appear first, integrating quantum radar into existing radar networks as augmenting sensors. In longer term, civilian applications like drone detection, weather sensing, or close-range imaging could emerge in more controlled contexts. In short, while the ambition is enormous, reality requires patience. The path forward is filled with technical trials, but each step taken wisely could bring this futuristic idea closer to reality. We just explored how China's programmable quantum radar could change everything, turning stealth from invisible to vulnerable, reshaping military strategy, and triggering a new tech rivalry. We've seen why it's exciting, what makes it special, and the tough journey it still faces in real-world deployment. If future labs prove it works outside the clean walls of test chambers, this could be a seismic shift in detection technology. And whether you're into astronomy or space exploration like me, you know breakthroughs like these ripple far beyond defense, hinting at quantum leaps across science. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. And don't forget to leave a comment below. Thank you for watching, and see you next time.